As we are done with the exercise, the final agenda is to summarize the model. What are the things we can learn? What are the things we've learned? The key things. So the key takeaways from this model, we have 3 key points. The first key point is that a chi-square distribution is a distribution of the chi-square statistic, simple as ABC. The chi-square statistic, as we know, is a single value that quantifies the difference between the observed value and the expected value from a contingency table, which is a matrix that is showing the frequency of occurrence of variables in an experiment. We also learned that the degrees of freedom determines the shape of the distribution, and the higher degree of freedom for a chi-square distribution, the more it looks like a normal distribution, but with a longer tail to the right. The second key point is the formula to determine the chi-square statistics, which is the sigma in brackets O minus E square over E square, where O is the observed value and E is the expected value. So basically, for each individual entry, we find the observed and expected value, the difference, we square that difference, and then divide it by the expected value for each individual entry, and sum up all of those entries. That's the formula to determine the chi-square statistic. And the third key point, there are 2 types of chi-square tests: a chi-square goodness of fit test and a chi-square test of independence. A chi-square gives a p-value. The chi-square test gives a p-value, which tells you if your test results are significant. If alpha is less than the p-value, then we do not reject the null hypothesis. But if alpha is greater than the p-value, we reject the null hypothesis. And we learned that alpha is usually selected at 0.05, that is 5%. Some may go as far as 0.1 or even 0.01. It depends on the context of the experiment or trial being carried out. So those are the key takeaways from this model. So we look at references. If you want further knowledge, there's a lot to cover in chi-square distribution and chi-square test. This just gives us a brief introduction to how it's done. So for further references, we have chi-square distribution, including chi and Rayleigh. It's a published work by Johnson, Henhel, and Kurt S. and Balakrishnan Hen, published in 1994. And you can also see NIST 2006 Engineering Statistics Handbook on chi-square distribution. That also gives you further knowledge. And there are also other references here. So for much broader understanding of this distribution, you can look at these references. These slides only cover a brief introduction. Notice that we also only discuss the test of independence in this module. So this brings to an end this video session on the chi-square distribution, and I hope you've learned a lot on it, and I will apply it in biostatistics. So thank you very much for paying attention. Bye.